Okay, everybody, this is Don Wedding, and we are in our quarterly show and tell class for Predict 498. It's now Data Science 498 Capstones. We have two sections of that here in attendance, and we also have our guests from the IDS 453 class, and some of them may be in the class as well. So we're going to have people talking on various topics, and our first guest tonight is going to be Nick Agarwal. Nick is a student in my section 53. So Nick, what are you going to talk about tonight?
So today I'm going to talk a little bit about tidy, the word tidy, and how it's like a programming philosophy for us in our group at John Deere, and also tidyverse a little bit.
Okay, great. So I'll tell you what you can do. You can share your screen and have at it.
Yeah. All right.
Okay.
Someone can let me know if they see my screen. Yeah.
You can see your screen, and also if you're not talking, then keep yourself on mute, folks, so we don't hear an echo. Okay,
right.
Nick, take it.
Yeah, thank you. So my name is Nick Agarwal. I am a data scientist at John Deere in the customer and product support team. So I work a lot with our aftermarket data, so like with dealer work orders and warranty data. And so one of the philosophies that we've adopted in our group is this tidy philosophy of data analysis. So this is it's part of this tidyverse nomenclature that Hadley Wickham, who's the chief data scientist at our studio, has introduced and has written a book about. And we've taken it and made it our mantra on our team, because we find that it's the most easiest way for us to code, and also the most easiest way for us to share our knowledge within our team and also within the company. And it's one of those growing seeds that a lot of our data scientist groups within Deere are starting to adopt. So today I just wanted to give everybody a really brief introduction to tidyverse and a little bit about how we do things in our group using this philosophy. So we'll start off with like the word definition of tidy. And what tidy means is essentially each column is a variable, each row is an observation, and each value has its own style. So if you see the table on the left with the green smiley face, you can see that every column name is provided, variable 1, variable 2, and then the respective observations underneath. And then the column on the right is actually what we would call a non-tidy data set, and that's something that quite a few databases, including in our side, are stored like that, but then we spend a lot of time wrangling the data so that it's actually in a tidy format. So from a visual perspective, this is how we teach our internal data scientists how tidy is visualized. So we have the variables going in columns, like I said earlier, the observations going across, and then the values are the individual observations that you're seeing within each column. So the tidyverse is kind of an interesting nomenclature. A lot of people talk about it, but really it's two different things. It's a suite of R packages that our studio has released, but it's also rooted in SQL. So what they've done is they've taken a lot of the SQL nomenclature that you hear about, like select, from, where, and they've implemented it into R packages, which makes it really easy to wrangle data and to focus your analysis while you're coding. And so it makes there's a lot of benefits to it, which I'll get into in a little bit. So Hadley has written a book called R for Data Science, and in it he talks about how the typical data science project looks like. And this right here is actually a really good representation of how we do data analysis at John Deere. So this is like a high-level overview. Essentially, you have these basic steps of importing data, tidying it up, transforming, visualizing, modeling, and communicating. And I'll kind of go really quickly through some of the brief steps that we do. So for example, when we do data exploration, we'll import, but we'll also do some quick visualizations, transformations, just to kind of get an idea of what the data is telling us before we do a full data import, because we have terabytes of information from our machines, and this is related to both our warranty and telemetry data for our machines. Then we spend a lot of time wrangling. So this is where we would import, we tidy it up, make it into that nice format where we have columns and variables are rightly aligned, observations are in the right spot. We then transform that information to help starting to create an understanding of what's happening. Tidyverse really shines in the programming aspect of it, because what it does, one of the key benefits of Tidyverse is it takes your information and it really makes your code readable. So that's the really big important step for us, because in our roles, we tend to work from project to project, but we need to make sure that our code can be read by anybody and the logic can be understood by anybody who has some familiarity with R. And then we do some modeling real quick, and then the communication, kind of like how Don has mentioned in this class and earlier, like you really need to make sure your message through visualizations and through your communication, presentations and whatnot needs to be clear and concise and to the point. So Tidyverse, as I mentioned earlier, is a set of packages. So these are like the main 8 packages that are equipped with Tidyverse. Actually, if you go to your R Studio install or any other R client and install package Tidyverse, you'll end up getting these 8 packages. And breaking them out, this is what they're doing. So these packages, they can be grouped in ways. So you have Reader, which is going to be good at importing data, basically coming in from CSVs or some other formats like text files and whatnot. The Tidier and Tibble packages, what they do is they take, Tidier is really used for manipulating data, like how it's arranged and how it looks. And Tibble actually takes data frames to the next level. It gives you a lot more flexibility on data frames than you get with just the data frame itself. Then you have the transformations like stringer, dplyr, per, forcats. dplyr introduces or has introduced a concept called piping, which is basically the percent sign, the right arrow, and then another percent sign. Piping essentially means that you take information from the previous step and pipe it into the next step. Stringer is a package that basically works with text. Per is essentially using these advanced functionality for mapping. And forcats is really neat. I use forcats a lot. And what forcats does is it's really taking factors and allowing you to compress them. So if you have, let's say, some kind of a variable that has 200 factors, you can compress it down to maybe 5, and it will automatically do it for you with using a variety of different options that you give it. So you can have proportions, or percentages, wherever you like. And then ggplot2 is really good for visualizations, and it's my preferred package compared to Lattice. Now, Lattice is still faster than ggplot when it comes to enormous amounts of data, but ggplot2 still continues to, in my opinion, look really beautiful graphics. One of the things you will notice that Tidyverse does not have is anything for modeling. So if we go back to to this page right here, we don't have anything for the model section, and that's because our studio is recreating a package that originally called Carrot, and they're actually breaking it apart and improving it, and that eventually will be joining Tidyverse in the future, and that will help give our studio a complete ecosystem of packages that will really help data scientists take their methods to the next level. So just to recap some of the benefits of Tidyverse, it focuses on readability. It's not on coding efficiency. So it's not designed to run like super fast on your machine or super quick or anything like that. It's meant to be easily readable by anyone. It also enables you to focus on the questions and the data that's in front of you. You really get a chance to get your hands deep into the data and understand it. Very consistent. It's easier transformations and modeling, especially if you're used to SQL, and it's a cleaner output. And I'll give you an example here. And this is a really simple example, so people who are really good with base hour might laugh at this. But really, if you look on the left-hand side, here I'm just trying to get an idea of how to aggregate and get a mean of using the iris data set of what the steeple length would be. But in Tidy, I can do this in a much more beautiful way by basically looking at the data frame, piping it, which is this symbol right here that I talked about earlier, grouping by species, summarizing, and ungrouping. So when you look at the Tidy side of it, it's really easy to understand what's happening step by step, line by line. And in terms of speed, both of them are going to be pretty quick, except the nice thing is with Tidy, it's really beautiful to read, really easy on the eyes, and it really enables anyone to understand what's happening. And that's the key for us at Deere too, is that when we take this information and pass it on to someone else or some other team, they should be able to read this information, read our code, and we may not always comment on it, but if they can read the code, they understand it. It's very easy to comprehend. And it's kind of what I had for today. Resources. So there's a great book by Hadley Wickham called R for Data Science. A lot of the graphics that you saw here were recreated from that book. And I hope, again, if you have any questions, I can take them now. And hopefully that gives you a really brief, really quick introduction to Tidy and Tidyverse.
Nick, this is really great. Can I get a copy of those slides to post them for the class?
Yeah, I actually emailed it to you earlier during the day as a backup.
Oh, yes, you
so
did. Yeah, I think you're ready. Oh, I'm sorry about that.
Yeah, no worries.
But this is really interesting, and it's kind of I can tell this is going to be huge. It's kind of interesting that a few years ago, some student did a talk on uh, uh, what is that thing that they use in Python, the environment,
Anaconda?
not Anaconda, but the tool inside of the environment that you
Spider?
write. Now, gosh,
Spider. Okay.
no, it's
Panda?
Jupyter
Panda?
Notebooks. That's
Jupyter Notebooks.
Jupyter
Yeah.
Okay. Yeah.
Yeah, and and the thing is, I looked at it and I thought this is going to be huge, and it was like nobody had ever heard of it, and somebody did a talk on it. I have a feeling that this is going to be another one of those things that in a few years everyone's going to be doing something like this. It looks like they're getting out in front of some of the problems that some of the criticisms of R. I think they're addressing it with this tidy. So this could be huge. But does anybody have any quick questions? If not, we'll move on to another person. Nick, thanks for finishing up early too. I really appreciate that.
Yeah, you're welcome. Thank you.
Great talk. Okay, so eeny, meeny, miny, mo. I'm looking at George Casey. George, you want to go tonight?
I do. You can hear me okay?
I can hear you great. Are you? What is your talk tonight?
So I want to talk a little bit about Azure, the Microsoft kind of cloud data service.
Oh, wonderful. So so we're going to let you go second then, and let's see if you can beat Nick's record here. Nick got done in 8 minutes.
All right. So 7:15. I'll see what I can do.
Okay.
And this is very kind of just a quick demo, but I found some value in this as we experimented for our group. So hopefully this will be useful. I will confess my title at work. I'm the Microsoft Innovation Leader at RSM, so I do a lot of consulting on Microsoft products, so I might be trying to sell you something tonight, but you never know. I'll try to dial it down. Basically, so this is for our 498 project. Our group, we are doing analysis on hundreds of thousands of rows of golf performance data to be able to provide statistics back to individual golfers about optimal performance and how to optimize schedule, et cetera. And one of the challenges we have was team members in, I think, 4 different time zones and trying to kind of coordinate on a common data platform. And so looking at the Microsoft kind of Azure SQL environment was interesting in that it provided a kind of perpetual environment that we could use to both read and write data. And then it would be useful downstream when we thought about app and dashboards in terms of having a cloud data source that could be accessible really at any time and not just for modeling purposes. So what was interesting and exciting, I think, about this for me was I went from no Azure experience or account to having a full working database in less than an hour. And I'll show a little bit about kind of, there's a wizard that walks you through that, so I won't go through that, but kind of show how I can interact with the database through multiple channels. So on my screen here, I'm just showing kind of the Azure portal. And if you were to go to portal.azure.com, you can use your Microsoft ID. One of the nice things they have is a free trial, and they'll give you kind of $200 of credit to apply to really any of the services. And kind of the next probably most interesting service to this group would be the Azure Machine Learning Platform, where you can do a lot more around kind of a visual drag and drop machine learning designer, but I'll leave that for another day. But you'll notice here kind of in my resources that I've created, I have a SQL Server and then 2 databases. So I spun up this first Albatross database. This houses our data for our project. And then just as recently as last week, I'm taking another time series analysis class and needed a quick data set to do for a Kaggle competition. So just another example, really quickly, the ability to kind of create a new resource with as simple as kind of following this menu structure. Within kind of this the database online, you have kind of full monitoring and management services. So now I can look at things and understand the health of the database, what's online, any resource constraints I may have with this database, how it's being used, kind of very lightly, you'll notice right now. But even go into far as kind of query the database. And so with this kind of gives me an online SQL query editor. I can just log on to the database but run quick kind of SQL commands, both for either inquiring in the data, or I want to do some updates and change some things, including kind of visual exploration. So we have three very simple database or tables here. I might say select top 10 star from player. And kind of right without any software on my client, I can just, through a browser, run these quick kind of SQL commands and look at, okay, I've got some golfers in this data set, interact with however I would. But that's kind of the source. Now, what's exciting and interesting, I think, is we can connect to this through multiple different channels. So the first and kind of what was interesting for us as a group was using R. And so the key here was we've got a library, this RODBC, that we're using to kind of make the connection. And then I specify just a few parameters like what's the server I'm connecting to, user and password, the database, and a driver. I use that to build this connection string. And then I build a SQL query. So in this case, very simple. I'm saying select top 1,000 star from round. I'm saying give me all the attributes and data from round. I'll go ahead and run that command right now. I put timestamps in here just to show kind of this takes for about 1,000 rows back. It took about 2 seconds. If I look at make that 5,000 rows, I'll run that, change my query, and then rerun the statement. And what I'm doing, I'm just loading this into an R data frame. So now I click run. Still, about a second, so you'll get a little variance there. I think the observation, or my observation, is, hey, for relatively workable sizes of data, we have up to 100,000 rows. This is manageable, but I wouldn't say it's lightning fast. I think when I came to do actual transactions, I was doing updates and write backs. R is still much, much faster. But for what we need to do, this is plenty fast. And so now I've got this data frame, 5,000 observations of 179 variables. I'll just do a quick view on that data frame, and you just get a sense of this is the data that's coming back from R into my, or from Azure into my R environment. I'll switch back here, and then I can run. At this point now, didn't really matter where the data came from. I have full R capabilities. I can do whatever would be appropriate or meaningful, whether I'm modeling my data, transforming it. Then the nice thing with this, I'm doing a read here. There's a full kind of update function as well. So if I want to write data back and kind of synchronize, and again, this is where it's beneficial over a flat file, because now I can have concurrent users interrogating the data, making updates, and have some kind of concurrency control through the Azure Database Management System. The final kind of component, or I guess I'll show two more things. If you are a SQL Server person, I kind of grew up in SQL Server. I've been doing it since 1997 and version 6.5, so I'm much more comfortable. And I think to Nick's point, tidyverse was interesting when I first saw it as it's SQL-like and it was more familiar, but I'm still most comfortable in SQL. Here you'll notice I can use, this is SQL Server Management Studio. So the same familiar tool set, but now connecting to the cloud. I've got this albatross.database.windows.net, but from here it's just like it was a local on-premise server, and I can run all my selects and updates. I can run all my scripts and really have full functionality that you'd expect with SQL Server if that's something you're familiar with. And then the final example, Power BI. So now looking at, I pulled that second data set that predicts sales, but being able to look and use Power BI the same way when I connect to that data, it understands kind of how to connect to an Azure SQL Server. So it's simply a matter of putting in that database connection string, your username and password, and now I have kind of drag and drop visualization. This, if you're not familiar, is the Kaggle predict future sales problem, and being able to kind of analyze this in real time with Power BI. One final component, obviously there'd be a whole session on Power BI that would be interesting if you haven't seen it, but you'll notice one of the controls here that you have the opportunity to add to your dashboard is an R script visual. And so now you can do anything you would do in R and kind of embed that into your dashboard and use that same data source. So I'll stop at that point and ask kind of for questions. And Don, you'll note 7:23, I think I tied Nick with his time.
Well, you're in good company, because Nick was a speedy talker. So let me ask you a quick question. First of all, can I get copies of the slide deck for the students? And if so, just mail it my way. But how difficult was it for you to learn this stuff? I mean, it looks complicated for a person who's not a SQL expert. How difficult would it be to get up and running in this?
Yeah, I think that was what interested me the most was that, I found this R script online and with a really quick search. So, hey, how do I connect SQL Server to R? As far as standing up the database, less than an hour to get everything up and running. And most of that was just the time it took to provision. So I think Microsoft's done a really good job of kind of giving you a wizard to walk you step by step. And there's lots of videos and additional resources for creating your first app or creating your first database that are there to support you. So they're certainly interested in supporting this. One kind of fact I found interesting, Microsoft's becoming huge in the cloud database space and just the cloud environment. And their current statistic they're quoting is 777 trillion transactions a day running through their data centers. And so they've got 80 to 80 centers across the world. And they're talking about putting data centers at the bottom of the ocean. I mean, really looking at innovation from a standpoint. So this is a company I think you can bet on from a standpoint of they're going to be around as a data source in the future.
Wow, that's impressive. So now I you got me mad here, George, because now I've got to learn something that I've already got a lot of things I got to learn. Does anybody else have any questions? I mean, I didn't mean to monopolize George's time here.
Sure, this is Nick. I had a question for you. Sorry.
Go ahead.
Does Azure SQL, does that have the ability to integrate directly with the location-based services that Azure offers, or are they two separate services that you have to run for let's say argument's sake geospatial analysis using SQL?
Yeah, so on that main dashboard, there are a bunch of additional kind of configuration options, parameters, and services you can start up. And so location services is one of those. I didn't choose to. I didn't have any need for that. But it really becomes robust in that context. And, on top of that, there are over 200 individual data services on the Azure kind of platform, all the way from Cortana Analytics, and they've got their whole machine learning suite, to things like backups and geo loading, load balancing. So I'm not an expert at that other than just knowing that they are continuing to add more functionality there. But if you look at that parameter screen when you set up a database, you'll get a sense of all the things you can do.
Cool, thanks.
Hey, Don. George, great presentation. I just had a quick comment.
Okay.
So, this is just in the context of Azure, so I thought I'll just speak up right now. Microsoft's annual developer conference called Build 2018 is going on right now. And we had a very nice keynote from Satya Nadella. And they covered a lot of very quick demos. And one of the demos was to enable IoT data streaming. And they built a very quick three-liner visual, app in Visual Studio to actually connect the IoT data and tweet something on, and it was very quick. I just wanted to say, take a look at that keynote because they have a lot of cool demos using Azure.
Thank you very much. That's very helpful.
Thanks.
Does anyone else have any comments, or should we move on to the next one? I try to keep things moving. Okay. Well, in that case, I'm going to now move over to Carrie Garrett. Carrie, are you ready to talk tonight?
I sure am.
Okay, Carrie, then I'm going to let you go. And what's your topic tonight?
I am doing a high-level overview of digital media analytics.
Oh, that's right. I'm looking forward to this one.
Yeah. Okay. So, can you see my screen?
I sure can, and 8 minutes seems to be the time to beat.
Okay, let me start my stopwatch so I can make sure.
Ready, set, go.
Let go. Okay, so looking at digital media analytics, I am going to talk about first the three major types of digital media. So when we're talking about digital media, we're thinking about search ads, and the most common of those are text ads. These are the ads that you see at the top of a Google search. You know it's an ad because it has this little ad square right there. So these are very common. I'm sure everyone has done a Google search before and seen those. In addition to text ads, there are also different types of specialty ads that are also different types of search. They're still under that search umbrella, but they might vary by industry. So one example are shopping ads, and those are these images, like I just did a search for black dress and took a screenshot, and then these images for different dresses are the shopping ads that come up. And so those are everything that is in this. These are all paid ads, so none of that part is organic. And you can see that it is paid because it has this little sponsored indicator right here. So those are one of the biggest types of digital media ads out there. Another one that's really popular are display ads. These are more commonly known usually as banner ads, although you can have text-only display ads in some cases as well. So I just pulled 2 example screenshots of these, one from CNN, where I actually got an ad for Northwestern's data science program. And then I also pulled a screenshot from New York Times, and these are both from today. And then this one's doing an ad for Amazon AWS. And then finally, I don't know if you guys can see this black box like I can. Okay, so finally, another type of ads are video ads. So these are things that you might see them on Facebook. The videos that play there, Facebook tends to, I'm pretty sure they still don't play auto sound. But then I just pulled an example from YouTube. I just pulled up a Binging with Babish, who's a really popular YouTube creator. He does like cooking videos, but an ad that came up on this is a skippable ad because I'm able to, after a certain number of seconds, actually skip that ad straight to the content. So those are the 3 primary types. So after looking at those, how are we going to measure those ads and their effectiveness? So there's all different kinds of metrics here. I'm not going to go through all of these right now. I'm going to really specify search ads right now, just for time's sake for this presentation. So looking at different general metrics, impressions are the number of times that the ad is shown, whereas clicks are the number of times that the ad is actually clicked on. Cost is going to be the total amount charged for all of the clicks on an ad. So you might, at the end of a month, have a certain amount of that you owe to Google or Bing or whoever for the clicks on your ad. Conversions are the number of valuable actions performed online after someone clicks on the ad. So someone clicked on an ad, it took you to a website, and then let's say you went to walmart.com and you ended up purchasing from Walmart, then that's going to be a conversion. Purchases are probably one of the most common conversions, but you can also have other types like signups or things like that. And then conversion value is going to be the value of those actions. So purchases is a really straightforward one because it's going to be, let's say that you went to, in that same example where you went to walmart.com, you ended up spending $50 on, various items. So from these more straightforward general metrics, you can get various derived metrics. So one is the click-through rate. So that's how often the ad is clicked compared to how often it's seen. And it's calculated with clicks over impressions. CPC is the cost per click. So how much is, on average, what are you being charged for each click? Of course, you could go and look at it on like an individual basis, but there's so many clicks and things, people look at that on a higher level. And then another one is ROAS, your return on ad spend. So this is very similar to like an ROI, except your advertiser, if you're working with Google, Google doesn't know what your profit is. They might just get the gross revenue because that's the data that the advertiser is sharing. So it's that conversion value over the cost. So instead of looking at it as like a 40% ROI, they're going to look at it as a 5-to-1. So you're getting $5 in revenue for every $1 that you spend in ads on advertising, for example. So looking through here, here are 2 different examples. So there's click-through rate. In this example, click-through rate is higher. On search ad 1, the CPC is lower. So those are both great metrics. However, your return on ad spend is actually better on your second ad. So even though you have a lower click-through rate and higher CPC, which might not be desirable, you have a higher ROAS, which is usually what people are wanting to do. So then we can talk about attribution. So you have when you're looking through on your path to purchase, you get hit with lots and lots of advertising. So how do you know which ad to credit for the purchase? And that's through attribution models. So there are all different kinds of these. I'm going to run through these really, really quickly. So last click is the most common and probably the most used, but is one of the least useful, where it gives all the credit to the last ad, the last click. First click gives all the credit to the first click. Linear divides it evenly among all the ads. Time decay gives more credit to the clicks closer to the conversion. And then position-based gives 40% to the first and last, and then evenly distributes the ones in the middle. And data-driven is actually the newest version, and that's where they use machine learning to distribute credit based on historical data. So then when we're talking about media measurement, so far it's just digital kind of as a standalone, but that's not how advertising works. You're spending by different channels. So there are two different ways to look at this. So one is media mix modeling, which is a top-down approach, where you're starting with at this very macro level, and you're looking at the total media cost and the overall revenue that you're getting. So that's historical data, and you have very delayed results, but it does include external factors. And this is going to be something that you can look at across all your media, even offline media like print, radio, and TV. And it provides insight into how media performed at a really high level. So you're going to be able to answer questions like, which media channels had the greatest impact on my revenue during second half of 2018? Or using your media mix model, how should I generally allocate my media dollars for next year across the channels? To do a more granular look, you might use something like multi-touch attribution. So this is going to be where you're looking at digital media, not just one partner, but various partners. So Facebook, Pinterest, Display, Google, Bing, all those different ones. So you're going to do a bottom-up approach. So it starts with each individual's journey and then rolls up from there. So it's a micro-level view. You have close to real-time data inputs and results on this one, but it excludes external factors. Again, it's just the digital media, but it's still very difficult to do because you have to match data across partners. So this is going to give you insight into the performance of digital marketing on a granular level. So you'll be able to answer questions like, what's the path to purchase for a specific audience, and how do I optimize that? And what are the synergies between digital media buys, and how can I improve them? So those are just a few examples in a very high level look. And that is all.
That was really interesting. I'll tell you something, Carrie, is that when I was at Sprint, we had an entire department that worked on this mixed media models and the attribution of the web stuff. And I didn't understand any of it, but this stuff was huge, and I think it's huge at pretty much every company. So whoever's on the call here, this is really important stuff to learn. How long did it take you to get good at this, Carrie? I mean, if somebody wanted to dive into this, how long before they ramp up and get, understand of this material?
So I think it kind of depends. This is a really high level look. So understanding what is there, I think, is easier than like really understanding the strategy behind it and how things work together and things like that. That's where it gets more complicated. So I worked at Google for just barely under 2 years, and I had zero experience in advertising before I started, if that helps at all.
So this was about 2 years worth. What if somebody doesn't work at Google and they're just working out there in the outside of Google? What about the outside looking into this? How long does it take to ramp up in that world, or would you know?
I mean, I've never done that, so I don't know. Everyone that I was working with, people mostly came from agencies. I was more of an anomaly that I didn't come from any sort of advertising background. So, I mean, to understand the basics, I think you can get pretty quickly. It's more of, so like what is even above my knowledge and stuff is if you're going to go really deep into media mix modeling, those are traditionally done with nonlinear regression models, which is why they're delayed and why it takes so long and things like that. And there are companies out there that only they specialize in doing like MMM and MTA models for these bigger companies like Sprint. So, those are like even more, I mean, you can go way in the weeds on either of those as well. So I think to get a broad overview, it depends on how much you're working on it and stuff, but to do something really granular is going to obviously take a lot more time.
Okay.
MTA, on the other hand, is primarily done with machine learning.
Okay. And as always, can I get a copy of the slides to post for the students?
Of course.
Thank you so very much.
All the data in here was completely made up. I made it up today. So.
Well, it's still, this is a great overview from what little I know of this topic, but this area is huge for anybody in the class who's thinking about getting into marketing. This is huge. So does anybody else have any questions for Carrie, or can we move on to the next person? Okay, well, guess what, Aaron Poe, you look, oh, yes, sir.
Oh, John, this is Catherine Talley. I just wondered if I could go. I have an early flight tomorrow, if you don't mind.
You sure can, okay. Aaron, you're going to have to wait because Catherine's going to go.
Okay, no problem.
Catherine, you should have said something earlier. I would have let you go first.
I did not want to go first.
Well, okay. Well, let's see how quickly you can do this so you can make your early flight. And I won't even ask you about the slides. Just send them my way if you feel comfortable sharing them.
No problem.
Ready,
Can you see my screen?
go. Yep, I can see your screen.
Okay, so I should have titled this. My title is actually Microsoft Power Query for Data Understanding, and I should have entitled this Tidyverse with Training Wheels. If I'd known Nick was going to talk about Tidyverse, he and I have had many conversations about Tidyverse, and this actually is born of those conversations and trying to get a handle on working with SQL-oriented things when you don't have a SQL background. So I'm not going to do a tutorial or anything. There's plenty of things online. I just want to highlight where this tool fits in the toolkit and what the circumstances are in which you could use it, and just maybe show some cool functionality to show it off a little bit. Definitely, way lower of a level than what George was presenting, but definitely one of the building blocks within the Microsoft universe. And I do not work for Microsoft. So in the CRISP-DM cycle, where this fits in is a data understanding. For me, where I find this tool to be the most useful is I have data, and I just prior to really getting into preparation and EDA, I just need to figure out what's going on with my data. You can do as much data preparation as you want within the limitations of the tool as well. So Power Query is for you or someone you know. If you are starting with a data set and you don't even know what you don't know about it yet. Cracking a Kaggle data set, a first-time exploration project for work, you're not worried about the data pipeline, you just need to get a mental map of your data structures to get started. If you have someone on your team who's visual and just has trouble, with the melt and the joins and all of that, this can be a really helpful tool to kind of on-ramp them into manipulating data. So just a word on where this sits in the Microsoft world. So Power BI is, as we know, a standalone application. There's been other presentations on that. It has your full business intelligence capability, and it goes from query to data manipulation, data modeling to viz. Within Power BI, the query editor tool is actually synchronous to the Power Query add-on that's available in Microsoft Excel for free in any version. And it is just the query and data manipulation piece of Power BI, and it's free anywhere that you have Microsoft Office. And so I'm actually going to focus on that because I use this very often at work. We do not have a sophisticated technology stack, and we have data all over the place. And this has really saved me a ton of time. So the advantages for Power Query are it's very loose with the recognition of data types. If you have poorly formatted data, you have question marks and numbers in the same column, things like that, you really don't have to get tripped up on that for too long. I really am a huge fan of the recognition and manipulation of dates and times in Power Query. I find it has a really shallow learning curve. It's very visual, it's very click-oriented, and it has a low, what I call punishment curve. You can recover from a really bad mistake in about 20 seconds or less, usually with the click of a button, and just kind of go back and get back online to where you were. And then you have an immediate visual feedback of your data manipulations for those visual learners. And if you want, using the add-on version, you can drop a clean CSV if you want to do all your manipulation there and start modeling in whatever other software you want to use, or start your visualizations, drop it into Tableau, wherever you want to go, and you have one clean data set. There's limitations to Power Query. Obviously, if this is part of a data pipeline, this is not your tool. If you're going to use it within Power BI, you're going to be in a Power BI file, which really isn't portable outside of that world. Yeah, but if you do want to drop it to a CSV, you're going to be stuck with the typical Excel row limitation. So, you know, data sets up to 100,000, 200,000 rows, you're going to be pretty fine, but beyond that. And there's some other limitations, including there's not a save button when you're manipulating or building your query, so you can crash it and lose your work. So there's some resources for the Power Query add-in. All the documentation and videos for Power BI apply to the Power Query add-in, so you can learn it either way, however you prefer. And I'm just going to quickly move into Excel, actually. And within Excel, I've kind of got some things pre-cooked here because of the time limitation, but you can open the query editor within Excel. I typically set up one query that just goes out and reads my data. I stick it all in one folder, and you can actually just point to that folder and get all your data. And just very briefly, from there, if I can reference that query and it just takes that previous query as a data source, I can pick a training data set that I want and import that CSV. Now, here's what it's doing. I'm clicking away and doing whatever I feel like doing visually, what makes sense to me. And over here, it's storing all of my applied query steps. I can go back and I can manipulate any of these steps. I can click on any one of them and I can kind of see the code that it's writing while it's doing that. And I can also manipulate these steps using the little cog here. So that's not a very interesting step to manipulate. I chose this data set. This is the West Nile data set from the Kaggle competition because it's a really weirdly organized data set. So I have a trap ID and different dates throughout the year where mosquitoes were trapped. But what I have is actually, my data, sorry about that. Multiple species, so there's a row for every species that was found in the trap. And then interestingly, this took me a little while to figure out from the documentation, no row represents more than 50 mosquitoes. So if there were 51 mosquitoes, it's going to split it out into a row with 50 mosquitoes and a row with 1 mosquito. Now, I can hold my own in R, but it doesn't seem fun to me to try to manipulate this just so I can see what's going on with the data and do a few graphs and things like that. I kind of want to just explore this and figure out how the data is structured and just to get the steps that are really going to be important to me and to visualize how I want to flatten this file. So, you know, skipping through a lot of things, I wanted to get to 1 row per trap. So I actually just referenced my data source again. Over here, I have my query that I built, and I was able to, in just a few steps, aggregate that to 1 trap, 1 row per trap per date with all of the other information that was relevant to that trap, and then aggregate the number of batches, which is the number of rows, the total number of mosquitoes, the number of batches, and then actually count the number of species. So I was able to just collapse all of that data, and I did that in 2 steps. And I can go back and just kind of show this happens to be a group row step, and it's all very visual. Just click and pick, basically, and you have a number of different operations that you can do to aggregate your data. I do want to just brag on the dates a little bit here. Sorry, I have to backtrack. Oh, I know what I wanted to do. So I can kind of do some manipulation over here. I'm going to delete until the end because I forgot to get rid of these steps. So actually, I'm just using this file because it has a date and a time. So if I want to change things in place, I can use transform. If I want to do feature engineering off of existing columns, I can do add column, and there's a number of built-in functions. And I love the date functions. So if I highlight a column formatted as a date, I can automatically calculate an age if it's a date of birth. If it's a date time, I can parse just the date. But I can actually just click on this column and I can parse out the year, the month is a number, the month is a name in case I want to have pretty graphs and I want to have that as a categorical. I can pull out the week. If I have, in this data file, we have a whole bunch of different dates, and really all I care about is to be able to forecast at the week level, so I can engineer everything to be the start of that week, whatever the first date was, and then that's going to allow me to aggregate my weather data for the week if I so choose. So obviously, all kinds of different manipulations that you can do here. Now, I know there are people on the phone who could probably code these steps as fast as I just did it. I can't. So this is where I find that this is a really powerful tool. And then, you know, I was able to take the weather data and aggregate it to the start of the week and the average weekly temperature for that date. And within about 25 minutes, when I cracked this data set, I was able to get a flat file with one row per trap per date and all of the aggregated data along with the average weekly temperature. So bang for the buck. I can do a lot really, really quickly with the data. I can understand what I did with it. If I happen to determine that I'm going to later need to actually hard code these for some kind of data pipeline in the software of my choosing, at least I have here something like a little bit of pseudocode that I can work from and go through all the steps that I'm going to need to do that I want to go through and go into tidyverse and code or whatever. Oh, that was my 10 minutes. So actually, if I wanted to load this to a table in Excel, I can just load to, and I can load it to a table. And then I can pop that out into a CSV or use it wherever I want. It doesn't have quite the interoperability of the things that George was talking about, but at least it's a start to get me to that. And I do just want to point out, you can pull data from URLs, all kinds of file types, any database that you have a connection to, the Azure things that were mentioned earlier, and then from various online services, ODBC, all of that kind of thing. So anywhere you want to pull data from and integrate it, you're able to do that really rapidly here. Sorry for talking so fast.
That's okay. But Catherine, so are all these things indigenous functions to Excel, or did you load them in? How did you get access to these functions? Are they in? Go ahead.
If you follow the link in the slides, you just download the add-on, and then you just go through your typical Excel add-on. It's really that simple.
Cool. And it doesn't cost anything? It's just free, or is it?
It's free.
Because we're students?
It's free for anybody.
Oh, really?
Yeah.
Well, then you got to send me those slides so I can send them off to the students. This might be another option for them.
Yeah, it's definitely. If people are just having trouble learning data manipulation, I think this is a way to. This is kind of training wheels for that.
This is.
And
more
also,
my
I'm just kind of lazy. I'm sorry.
I said this is more my speed. Does anyone have any questions for Catherine at all? I know she's got a plane to catch, but I want to. Okay.
Fantastic.
So, thanks so much, Catherine. So, Aaron Poe, do you want to go now?
Yeah, sure.
Okay, let's see. Let's see how quick we can go.
Okay. Can you see my screen?
I can. And what is your topic, Aaron?
Okay, my topic is marketing automation. So I work at a high-tech networking company called Zycel, and I'm the director of a marketing department. So I'll share the experience on using the marketing automation platform. We use that to measure the result of the email blast, blog activities, website traffic. If time allows, I also want to show you the heat map to understand the popular section that people clicked when they visit our web pages. So this heat map is different from the one that we generate to understand the correlations. Okay, just give you some background before I jump into the platform. It's always difficult to show the ROI from the marketing standpoint. You might hear this joke often that the only function that marketing has is to spend money. So it's better for me to show the boss we have the marketing intelligence to trace the results and also how we can integrate with sales. So we compare most popular platforms and narrow down to HubSpot and Marketo to be our final list. And after the careful considerations on all the features, user experience, and the cost, we decide to go with HubSpot. More we use it, more I love their friendly user interface. So I'm going to show you. Here you see that's a marketing dashboard. Basically, we can create different accounts for different group. So we have a group for marketing, so you can see different items. And if you are sales, and we create an account for them, and the thing they see will be different from the marketing group. We don't want them to go inside the platform and kind of mess around with the one we already built. So I'm going to use the example from the webinar invitation that we just sent this morning. That will be under contacts. Oh, sorry, I will have to go back to the marketing platform. So we'll have more analytics report to see. So under that, if I click on the forms which we send out the invitation. So this one is the webinar invitation we built. And once I click on submissions, I can see the quick overview of how many people views and what's the conversion rate. Right now it's about 23%, and I consider that's a pretty high conversion rate. So for this one, you can see all the people we sent, and they have some engagement with this invitation. And if I'm the salesperson, or even I'm marketing, I want to understand the user behavior when they receive this newsletter, where they click, or even they go to our website to see. So I will click on this customer's name, and you will see the system already automatically match the customer's name along with their company, and we'll have all the profile on the side. And we'll show all the details about that company and the size and the annual revenue. And this person, they basically he checked on our website. There's 5 times he visited our website and 57 pages viewed. And it shows the first time he visited and the most recent visit. So check on the workflow on what he is checking. In the beginning, I can see from the detail, he come to our website at the day and the time and look at which page, and then go up. So basically, we will see all the behavior where he had visited. And then finally, today we sent him the invitation. So we saw him, we sent and delivered to him, and he opened it and clicked on the register for the webinar link. Then after those actions, he becomes one of our qualified leads. So the sales can go there and send the email. Right now, I haven't sent any email, so it doesn't have any record. But if sales log into their own account, they can see this customer and send the emails or call them. And this one is the insights for us to trace how people interact with our website. And when I introduce the system to sales, and they were surprised to see all the interaction. We can trace the customers, and they even asked me, "Can you see my activities? You know when did I click on which one?" So there's a mechanism. Of course, they have to be invited and has their information in this database, so we can trace their activities. So next one I want to show you is the blog. We do have our blog site, but we build this blog and post all the articles through this platform. And that's here. So basically it shows which one will go to a analytics report. So we'll see the performance of all the blog articles, and we'll see which one has the most page views and what's the most popular one. So we can figure out, or we can adjust our direction for the future articles when we draft it. And also that's the important reference for us to create any future campaigns as well. So it seems like people are more interested in next-gen Wi-Fi compared to some routine, like Wi-Fi isn't up to speed. It seems like pretty old now. So that's the blog. And also lastly, there are so many features on the dropdown, but due to the time limitation, I'll just jump to the analytics tools to trace our website traffic. So I know there's also the popular tool, Google Analytics, that a lot of people using. We are also using it, but this one is good to combine with all the activities, and then it has details like which one people view the most and how long they stay on the page, and then we can share the information with sales for them to follow up or kind of see which one we have to emphasize on the promotion. So this is the marketing automation platform that I want to share with you. I also want to show you the other interesting platform called Crazy Egg. So basically, the Crazy Egg is showing the heat map. Let me show you in real. We create this. Yes.
We're getting close on the time though, Aaron. So.
Okay, sorry. Yep. 30 seconds for this one.
Okay, fair enough.
Yeah. So the page just show you what's the most popular people hit on the page. So you can see the overlap if people click on the buy now button or any place they are interested in any particular product. So we can improve on our campaigns. So that's it.
So Aaron, is this a tool that your company produces, or you guys are using this for your day-to-day job?
We are using it for a day-to-day job.
I see. And who makes this tool? I've never seen this before.
You mean this one or the marketing automation?
The marketing automation one. Who made that?
This one called HubSpot. That's a company, HubSpot.
Hotspot, HOTSPOT?
HUBSPOT.
Ah, okay. I've never seen that before.
Yeah, they're too, this platform is really powerful. They can do a lot of things and easy to set up.
Well, that is really, it seems like everybody tonight is either doing something with data or something with marketing. Those are the two areas that are real hot. And I'm wondering if this is a bellwether for where the field of data science is headed. But so this was interesting. I enjoyed this. Does anyone have any questions for Aaron? Aaron, I don't suppose you're allowed to share some of the slides or the materials for this.
I can put some slides to show some highlights.
That would be wonderful if you did, but no pressure. If you can't do it, that's okay, but it would be very helpful if you did.
Okay, sounds good. Thank you.
Well, Julie Overcash, last but certainly not least, you get to go.
Great.
What's your topic, Julie?
Your electronic health record.
Oh, okay. Electronic health records.
Can you see my screen?
Not yet. Still no.
Not yet. It should be sitting there.
Are you sharing your whole screen, or are you just sharing your, there should be something on the very top.
Yeah.
Center of the screen where you share your screen. Oh, something's happening. Yep,
Yeah.
I see it.
Now can you see it? Are we
Is
good to go?
Yep, and it's got a snake and a wings thing there.
Yes, dear to my heart.
Okay.
So I will move through this. I am passionate about electronic health records because they can be used to improve people's health. You should be interested in because you probably have one. Also, I perceive the healthcare industry is lagging behind other industries in data management. There is significant potential for employment for data scientists in healthcare. To give you some information about myself so you know where I'm coming from, graduated from medical school 30 years ago. I'm a pediatrician, worked in clinic and hospitals in Illinois for the past 29 years, and I also worked in medical administration for the past 11 years. For EHRs, I've used Epic, both in clinic and hospital, Meditech, and Allscripts Sunrise Clinical Manager. Now, the EMR really was just an electronic version of our medical chart. The EHR goes beyond that. It interacts with your business office, other clinics and hospitals, pharmacies, data analytics groups, apps, IoT, laboratories, ordering, for example, radiology procedures. I tell you quite frankly, the government has pushed healthcare providers to adopt EHRs. It is tied to reimbursement through MACRA with the Medicare Access and Chip Reauthorization Act, and through MIPS, the Merit-Based Incentive Payment System, previously known as Meaningful Use. And honestly, the government wants the data. There are many EHR products. This adds to problems with interoperability. Epic is currently the dominant player, especially in the hospital realm. There are EHRs in various stages of development. Some are much more robust than others, which also gives you difficulties with interoperability. And just to give you an idea about their adoption, the EHR adoption in physicians' offices from 2004 increased to about 75% in 2015. Many other uses, evidence-based tools, for example, what's the appropriate study to order for back pain? Tracking treatment metrics, how much radiation has this individual been exposed to? Obviously, we talked about compliance with government programs, interacting with pharmacy services, dosing, electronic ordering. For process improvement, I would tell you we are tracking healthcare providers' compliance with standard of care. How are patients moving their healthcare electronically? I want you to note the usage of secure messaging at 64%. 1/2 of patients were offered access to an online medical record in 2017. 53% of those patients accessed the record once during the year. So patients are using this technology. And what are they seeing? Lab results, medication lists, office visit summaries, allergy lists, immunization records, and not as robust with the clinic notes. Accuracy, honestly, I'm your healthcare provider. I was not trained to enter data. I guess enough said about that. Inconsistent understanding of words. What does abdominal pain exactly mean? Are we supposed to also indicate the location severity? Data from outside organizations doesn't always align with my data. For example, immunization records come across and they have different dates. Do I just pick the ones I think are most appropriate? And honestly, physicians really don't know what needs to be included in data in electronic health record. Distribution of data, I mean, honestly, physicians do not plan where data should go. We can't even decide in our own chart. For example, pulmonary function tests. Does this go under the lab tab? Does it go in a physician note? Quite frankly, the real estate on the lab, on the tab bar is very precious. So it's difficult for us to even come to a consensus about where to house data. It's very difficult to pull the data you need. In this chart, majority of it's from text, but quite frankly, we also have physicians who draw, and sometimes they'll attach pictures. The quality of data that's being exchanged is typically very poor. What I get from the emergency rooms is typically worthless. I'll get names, maybe diagnosis, date of birth, medication, but I really don't know what happened there. And I touched on interoperability before. The EHR systems cannot talk to one another. I want to touch some on privacy. This is governed by HIPAA, the Health Insurance Portability and Accountability Act, and state laws. You have the right to get a copy of your record, request any mistakes be corrected, and quite frankly, that's not unusual. Physicians cut and paste like everybody else. Know how your health information is being used and shared. Say how and where you want it, how do you want to be contacted by your healthcare provider. File a complaint if these rights are violated, and your healthcare provider's office or hospital should give you a notice of privacy practices. HIPAA requires me, the healthcare provider, to have access control. So we're talking passwords, PIN numbers, sometimes it's two-factor authentication such as Duo. Encrypt your information. So we cannot use emails, we can't text you, and I cannot download this to my computer because my computer is typically just password protected. We have to have audit trails. We have to prevent data breaches. Significant firewalls are built into our systems at hospitals and clinics, so there are a lot of websites I cannot access. If there is a data breach, so if your data is seen by someone who should not see it, federal law requires me, the healthcare provider, to notify you, and the organization can be fined, mega money. Interesting, we're moving toward patients being able to release their own information. So rather than me trying to push the data from one healthcare provider to another, you have it on your phone and you decide who you're going to push it to. IoT is another potential source of data breaches. So what if there's a malware in the app? Who's responsible for that breach? Did I not protect the data adequately in the health record, or was it the patient who downloaded the malware to begin with? And FYI, once a patient pushes data to me through the IoT, it now becomes protected by HIPAA. So just my insights and opinions as a physician. One, I did not go into this discipline to type 2 hours a day. The EHR is supposed to make my life easier, but in some respects it's making it harder. I used to dictate 30 charts an hour. Now I type 10 charts an hour. So it's increased my charting time significantly. It can be difficult to conform to the templates that are used in the EHR, and it's sometimes perceived as cookbook medicine. There are multiple different EHRs to learn. I know Epic, Allscripts, as I said, it becomes difficult to move from one platform to another. When institutions transition to EHRs, they typically do it as a progression. So I'm dealing with paper and computer at the same time, trying to figure out where the information's at. EHR records can all look the same because you're using templates, which is very difficult to defend in a court of law when you're trying to defend your patient care practices. I want to talk to my patients, not face the computer. When there is a power outage at the clinic, we have closed the clinic. We continuously need to update the systems, which essentially means I have to relearn the EHR every time we do this. One thing that's outstanding, though, I can read everybody's writing. I thoroughly love e-prescribing. It significantly decreased my errors in prescribing medications to patients. I can provide vast amounts of information to my patients very easily. I can pull information on a disease condition into my chart, which is an electronic messaging system, and they can quickly view that on their computer or phone. I can connect information. So I can connect the patient's allergies to the medications I'm ordering to pick up on any errors. I can access the record from many locations anytime. However, I will tell you this is creating an incredible work-life imbalance for physicians, and we're experiencing burnout. Now, I certainly believe that integrating to an EHR must be done. It is my passion. It has an incredible ability to use data to improve care in a way that we just cannot grasp yet. We can only change what we measure, and this is one way to get there. And physician support is developing. Scribes, new occupation has certainly helped me get information into the record. And one day, honestly, this technology is going to replace physicians. You're going to make a diagnosis based on a picture with respect to dermatology problems. So 2 quick slides in closing. I want to provide individuals' perception of privacy and accuracy. 1 out of 10 patients are withholding information from their healthcare provider due to privacy or security concerns. This disrupts the physician-patient relationship. And 76% of patients prefer to speak with their healthcare provider directly rather than access their online medical record. So the greatest barrier to successful usage of EHRs is changing the culture of my patients. Thank you very much.
Wow, this was interesting. It looks to me like, as it stands right now, it would be difficult to mine this data and build any predictive models because of the data issues you stated. Am I correct in that?
I don't think so. Actually, the organization I was working with initially was doing a very good job mining their own data. So I think within a unique organization, when you're dealing with very specific data set that you're controlling, I think you can get some great results. But across the board, we're having significant problems doing that.
Very interesting. And of course, as I've mentioned before to everyone else, can I get a copy of the slides?
Certainly.
Thank you very much. Does anyone have any questions for Julie? Oh, I didn't know you were a doctor, Julie.
Yes, I am, sir.
Well, that is impressive.
Thank you.
So, and now you're going back to school, which is even more impressive. Well, I think last but certainly not least, we have one more, and this would be Dan Butler of Team 74. Dan, what are you going to be talking about today?
Okay, I am going to be talking about quantified self and personal data analytics.
Wow.
Can everyone see my screen?
I sure can.
Okay, great. Well, we'll get started. Yeah, this is something that I got into. It's actually this idea of running data analysis against yourself is what got me into this program. And I'll explain a little bit more about that later. But to start out with, there's this new movement. It's called Quantified Self. And one of the founders of the movement described it as self-knowledge through self-tracking with technology. And another way a lot of people think of it is it's, N equals 1. So you have an experiment with health or with anything about yourself, something you want to know, with a sample size of 1, which is kind of interesting. It's the idea that, we're all unique. And so what it does, a lot of the technologies that it uses are things like, Fitbit, sleep trackers, scales, blood pressure monitors. as you get more extreme, and the Quantify itself was incorporated. It was sort of a loose knit group of people. They created a company that's actually called Quantify itself, and they have all these user groups all around the area. So probably wherever any of you live, there's a Quantified Self group somewhere around there where you can talk to data nerds who are wearing all sorts of interesting devices. So, for example, there was someone who was wearing a smartphone that just every 10 seconds took a picture. So he had, for the last like 10 years, every 10 seconds of his life recorded for what he saw. They're big into, the people who go a lot of times are big into gut biome and DNA testing. There'll be one person in the group that I'm in locally wrote something that monitored the variance in the click time and how accurate he was clicking on things to determine whether or not he was stressed or not. So throughout the workday, he was able to determine his stress level based on that. And then I think at some level, the idea is it would maybe drive something then. So if you're getting too stressed, they'll say like, hey, stand up, go meditate, something like that. So personal data analytics, it's sort of a term I use just because Quantify itself is, that's a corporate term now. Personal data analytics is the idea of just using personal improvement through incremental change. So you decide what you want to measure, you measure it, you make observations on that data, and then you make changes, and based on the changes, you continue that cycle. It's, the scientific method, but again, it's with a sample size of one, and that's just yourself. So the simple steps are pick what you want to improve or understand, pick what you want to measure or what you're already measuring, and then make the observation and analyze the data. So I'll take you through two quick examples of that. The first one is, I'm not going to go into the details, but I had an undiagnosed medical condition that caused me lots of issues, and I was struggling at work to do essentially as good of a job as I thought I could. I started collecting data, so simple things. As you see here, I collected the dates. It says performance here, but it was the measure I called performance at work, and I had 3 measures. And all of this was before I was in the program. So there were things that I would do differently now that I'm a little more experienced with data analysis and collecting data and all that stuff. But this was sort of my first attempt. So I essentially just recorded everything into Excel. I had a performance at work was a 1 to 3, so 1 was low, 2 was medium, 3 was high. I had sleep. I recorded my sleep, whether I went to weightlifting or did aerobics, whether I ate healthy, how much tea I drank, how many diet drinks I drank, just all sorts of things that I could enumerate throughout the day. So I did that. I recorded for a little bit, and I had a baseline of data. Here's my original breakdown. Like 70% or 30% of the time, I considered myself high performance. Another 50 to 60% was moderate performance, and then low performance was about 10% of the time. So I'm just trying to solve what I perceive as this issue. I'm still working with doctors to actually solve the issue, but I'm like, hey, while they're looking through it, I can be doing something as well. So I collected this data that I showed before, and then I did what amounted to, at the time, a really simple analysis of the data. This was all I was able to do. And I'm not going to get too much into the analysis because most people here have a lot of experience in analyzing data. And so you will be able to do it, much better than I did at that time. But all I did was I went through Excel and just looked at the trends. So at this top row here, I have performance at work. And here, I'd look at, if I did weights or aerobics. So you look at the days where it was lower, or the days where I didn't do weights or aerobics, it was a little lower than the days I did do. The days I slept a little lower on average. You can see there's maybe a slight upward trend. This one here is a really steep downward trend, and that's the number of diet drinks I drank. Kind of interesting. Eating healthy improved it. So going back to the presentation, so I had my baseline data. I had all this other data that I was performing some simple analysis on, and I made a couple small tweaks. So the first thing I did was I said, well, diet drinks are bad, no more than 2 a day. Exercise looks like it's good, so 2 to 4 miles a day of walking 5 days a week, and then 2 or more cups of tea 3 days a week. And then what I did is I made those changes. I applied them, and if you looked, like everything looks better now. And I actually, as a result of this, added this fourth category, exceptional, which was, I didn't even have this as an idea of like when I got done with those things, like, wow, how did I even do that? You know, just like 100% able to concentrate throughout the day, able to get everything done. So I did that for 60 days. I validated that it was the same. I was getting those sort of expected results. Then I did another analysis. I found 60 days, once I got less than 60 days, I wasn't able to get enough data. That's the problem with doing anything like this, where you have small sets of data, is it's hard to do analysis when you don't have that much variability. So I did the second set of changes, where I did interval training 6 days a week, weights and interval training, or interval training, 2 cups of tea every day instead of every couple of days, and then no diet drinks at all. And you see that improved it quite a bit more. And then again, I did another 60 days, came up with a third set of changes, pretty simple. And this is where I ended up at. I was at a space where a category in terms of performance of how I was doing at work that didn't even exist when I started was over 50%, or was slightly under 50% of my time, the days I was at work. So it was a profound change in my ability to work effectively, and sort of that got me to sort of this mantra that incremental personal change is like compound interest on personal performance. You make small changes every year, you make small changes, you're measuring stuff, and that really compounds to you're a lot better performing with. And so, you know, at work, I've noticed a significant improvement. The medical condition was solved. It wasn't anything, and it, you know, that obviously helped. But all of these things actually did kind of point to the cause of the medical condition. There, all the things that were, for the most part, effective at making positive change were anti-inflammatory. So it was an issue that was causing some excess inflammation. So I was able to not diagnose this disease, but I was able to mitigate some of the impacts of it. So the only other sort of, I've learned a lot of fun stuff. Other fun fact maybe is that seeing a bear increased my heart rate about 30 beats per minute. So this was something, I did a lot of hiking last year, and I wore a Garmin VVO Active HR. It provides these exports where you can see it gives distance, elevation gain, elevation loss, average pace, things like that. I built, and so here's the hike I went on. I was hiking up here, down here, and then you can see I hit here, I stop, and I start backing up. That's because that's where the bear was. And so what I did is I built a predictive model, excluding the data where I saw the bear, based on hikes around that time. And then what I did is I looked at the error for those particular readings after I had seen the bear. So I did that. I built a linear regression model. I built a random forest and a GBM model, and they all sort of agreed that it was about 30 beats per minute afterwards. Now, that's a cool fact. I'm not sure how useful that is in my life. I've only encountered one bear, so I found a lot of other things though. This is just an example of some of the things. I drink 2 cups of green tea and black tea every day now. I have to sleep over 7.5 hours for the last 7 days. Blue light, I know a lot of people think that's a myth, but for me, I found anytime within an hour and a half of sleep, it causes me issues. Caffeine after 2 p.m., there's a 30 to 40% chance I can't fall asleep until half of that time, the offset between 2 p.m. and when I had the caffeine. More than one diet drink is my kryptonite. Bears increase my heart rate 30 beats a minute. I should meditate more. I drink lots of soda when I'm stressed, and my exercising, this was probably the most impactful one in the end. My exercising is almost perfectly correlated with the preparation of my workout bag the night before. So if I'm able to do that, if I'm able to get my workout bag done, then I will go exercise the next day. So that's the end of it. It's just an idea. Like, we're all good at data analysis. We're all looking at all these problems outside of ourselves, but you know, it's also, I think, good practice to look inside and start analyzing your own health and your own well-being. That's everything for me.
I think this was fascinating, Dan. I really enjoyed this. Julie, you're a doctor. What do you think? What made the diet pop? Why is that so bad?
There are a lot of chemicals in diet soda. A lot of people really don't recommend you drink it. Water. I'm a big fan of water.
Yeah, but I like Diet Dr. Pepper an awful lot. So
No, water, Donald. It has to be water, Professor. Water.
Well, I will say that the one diet drink that doesn't seem to impact me is called Zevia. It's kind of expensive, and it uses some non-FDA approved sweetener, so I don't know how good that is. I think it's not FDA approved. It might be FDA approved.
What about black coffee? I drink that by the pot.
Water, Professor, water.
Do not. I don't like coffee that much, so I don't drink it. But I know a lot of other people in Quantified Self say it's not bad for them. So, but
we got poor Julie keeps giving me the answer I don't want to hear, so I'm going to stick with Dan here. Next thing you're going to tell me, Julie, is that I shouldn't be sitting on the couch eating Cheetos all day.
Correct.
This is, you know what, Dan, I really enjoyed this topic, and just here's an empirical observation that I have made over 20 years in this space, is the people who are the best at doing analytics are people like you who do it for fun, and you've got your own little personal projects. That's how you get good at this, is when this to you is a fun project and you've got a motivation, whether it's doing this or analyzing baseball data or stock data or whatever. This is the type of person that ultimately does really good at this, is when you do this for fun or have a motivation for it. So, but this is fascinating. I really enjoyed this.
Well, it is. It's a lot of, it's been a lot of fun. It's definitely, and it is like the first part I showed is what got me into this program. I was like, wow, this is cool.
Well, I just am thinking, gosh, I wonder if that stuff, you throw a decision tree at that, just a simple vanilla decision tree and see what you get. I bet you might come up with some real interesting rules. Anyways, hey, do we have anybody else? Do we have anybody else who might want to talk tonight, or do you want to just call it a night, folks? I think you got a real fan club here, Dan. A lot of people are really enjoying this. I enjoyed it too. I thought this was a really cool topic.
Yeah, that was fun.
And it's really neat to have it right after Julie's too.
Right. Yeah. I think one person in the group described the Quantified Self as sort of alpha testing medical advice on yourself, which I think is a good description.
You're your own little guinea pig. Anyways, well, I don't have anything else. I'll everyone, please, whoever, there's no pressure, but anyone who wants to send me their slides, I would really appreciate it, and I'll post it for future generations. But if there's some reason you can't share, confidentiality or whatever, not a problem. You still get your bonus points, but whoever wants to share it would be grateful. So I'll try to get these things recorded within the day then, and I'll get the recording out to post the audio recording of this as well. So let me put a stop to the recording.